So last class we have seen what is coupling constant and how it couples with each other, how the protons couple and what kind of protons will couple with the other kind of protons. So only chemically non-equivalent proton will couple with each other. That you keep in mind. Okay. So if the protons are chemically equivalent, then they will not couple with each other. Let's keep this in mind. Okay. Now, suppose I take a benzene system. Okay, suppose I take a benzene system. Okay. So this is a different substance on both the ends. Okay. So now what will happen? These two hydrogens will be chemically equivalent and these two hydrogens will be chemically equivalent. So I can label this A, B, B. Now how will the spectrum look like? How will the spectrum look like? So aromatic protons, how will be the spectrum for aromatic protons? Will they say? Because these two are same, they will say some value. For example, there's 6.7, 2 hydrogen. What will be the splitting of these A protons? What will be the splitting? How will the A will be split by which protons? A will be split by
HB protons.
B protons. So what will be the splitting? So you'll be having n plus 1 rule. So you have one neighboring proton, therefore you'll be having 1 plus 1, therefore you'll be having 2, therefore you'll get a doublet. Okay, so I have a doublet. Similarly, for B protons, if I say, so A proton 6, I'm just giving an approximate value. Suppose a 7.3 B proton, for B proton, 7.3, 2 hydrogen. How will be the B proton split up? How will the B proton split up?
Doublet.
Doublet. Guys, keep this in mind. Most of the problems, they'll give you this doublet and doublet. Aromatic region, whenever you see this doublet and doublet, keep in conscious, you should keep in mind that you have 2 hydrogen, 2 hydrogens. So totally how many hydrogens? Totally how many hydrogens? 4 hydrogens.
4.
So 4 hydrogens are left. In benzene, how many hydrogens do you have in benzene? In benzene, how many hydrogens do you have?
6.
6 hydrogens. So in 6 hydrogens, only 4 hydrogens are showing the signal. Means what does it mean?
2 substituents.
Yeah, there are 2 substituents. Very good. So there are 2 substituents. Now the 2 substituents can be either para substituted or they can be ortho substituted or they can be meta substituted. Is it not? So it is di substituted. So di substituted can be either ortho, para or meta di substitution. Okay, so you can have 3 types of substitution, but it is di substituted. So if I have signals for 4 hydrogens, I know that I'm going to talk about, or I'm going to look at a problem where there are di substituted. So if I have somewhere it's given only mono substituted, so straight away I'll rule out the problem. Okay, rule out the answer. Okay, so now in this particular case, 4 hydrogen, if they say 2 hydrogen doublet, 2 hydrogen doublet, then what will you say? Then what will you say? They are, the substitution is what kind of substitution?
Para substitute.
Para, very good. So just you will observe when I discuss today. This is one important trick or clue in NMR solving problem. So whenever you see this doublet and doublet in aromatic region, you should be very clear that it is a para substituted, because if I have 2 different substituents, there is X and Y in ortho. So if I have ortho, can you tell me what will be the splitting pattern if I have ortho? In ortho, what is the splitting pattern? These are some important things which I cannot miss, because if you know this, we can easily propagate through the problem solving. Okay. So I can have para di substitution, ortho di substitution, or meta di substitution. So suppose I say X and Y, X and Y, X and Y. Okay, so here I'll be having, so when I look into different types of protons, different signals, I'll be having 2 signals. So AA, BB. Whereas here I'll be having how many signals for ortho? How many signals for ortho? A, B, C, D. How many signals?
4, ma'am.
4 signals. What about meta? Meta, how many signals? Already this we have discussed in detail in the previous classes while discussing number of signals. In meta, how many signals?
4, ma'am.
Yeah, so A, all are different. All the protons are different. Only in para, you'll be having similarity because you can cut the molecule like this. So these two hydrogens will be this. So these two will be equivalent. These two will be equivalent. Now, when I see para, I'll be having this will be doublet and this will be also doublet. Okay. But when I come to ortho, this A protons have one neighboring proton, so A will be doublet. B has two neighboring protons, so B will be triplet. C has two neighboring protons, therefore C will be also triplet. D has one neighboring proton, so D will be doublet. So when I talk about para, I'll be having doublet and doublet. Whereas when I talk about ortho, I'll be having a doublet, triplet, triplet, doublet. And when I talk about meta, this has no neighboring proton, so this will be singlet. This has one neighboring proton, therefore this will be doublet. This has two neighboring proton, therefore it will be having triplet. And B has one neighboring proton, therefore B will be doublet. So for meta, I'll be having a singlet, I'll be having a doublet, I'll be having a triplet, I'll be having a doublet. Guys, are you listening to me? So whenever I have only doublet and doublet, I should be very confident that they are para disubstituted. So any options which bears ortho or meta substitution, you can straight away rule out them. Guys, is it clear to you people? Is this clear?
Yes, ma'am.
Yeah, so this you keep in mind, okay? So while solving problem, this is a major clue for solving the NMR problem. Okay, let us see. So initially, I'll be having some problems on chemical shift and the coupling constant. So for that, suppose I have a triplet. I have a triplet at delta value 3.6. Always remember that the triplet or a doublet or a quartet, the center of the multiplet will always lie on the chemical shift. So if I have a triplet, I should not say that the triplet here it is 3.6. No. So triplet or center தான் எப்பவுமே chemical shift value நம்ம சொல்லுவோம். So ஒரு multiplet ஓட centerல தான் you have this chemical shift value. So 3.6 delta. Okay, so the multiplet will always rest on the center of the chemical shift. So suppose I take a quartet. Sorry, guys. Suppose I take a quartet, the center of the quartet, this will be your delta value. So always a chemical shift will lie on the center of the multiplet. Okay, and the distance between the lines of the multiplet, the distance between the lines of the multiplet is what is known as coupling constant. So coupling is between two hydrogens. So here we're talking about vicinal coupling or whatever be the coupling. So the distance between the lines of the multiplet. So be sure that the lines are adjacent lines. So either I can take this or I can take between these two lines or I can take between these two lines. Whatever you take, you should take the coupling constant value only between the adjacent lines of the multiplets. So what is coupling constant? Coupling constant is measured in hertz and coupling constant is the distance between the lines of the multiplet. It is a measure of coupling between two hydrogens and it is observed or calculated by finding the difference between the lines of the adjacent multiplets. Okay, so ஒரு multipletல ரெண்டு line நடுவுல இருக்கிற distance தான் நம்ம hertzல இருக்கும் because we are measuring in the difference, so it will be in hertz. Okay, so it's hertz. So நம்மளுக்கு இப்ப value deltaல வந்திருக்கு. So delta, so எனக்கு என்ன வரும் இங்கல நீங்க distance na delta value தான் கிடைக்கும் எனக்கு. So delta is given in parts per million. So suppose ஒரு spectrum கொடுத்து delta value கொடுத்து coupling constant value கண்டுபிடிக்க சொல்றாங்கன்னா, suppose you have, for example, I have the lines of the multiplet இப்படி இருக்கு, lines of multiplet இப்படி இருக்கு, சரியா? And இந்த ஒரு line ஓட delta value சொல்றாங்க. They're giving the delta value in the sense, in ppm, they're giving the values. So from the ppm, how should I find the coupling constant? Just multiply the ppm with the megahertz of the instrument. Okay, ppm is 10 power minus 6, mega is 10 power 6, rendume cancel ஆயிரும். So what you get is in hertz. So வந்திருக்கிற அந்த டெல்டா வேல்யூல இருந்து இன்ஸ்ட்ருமெண்டோட மெகாஹெர்ட்ஸ் மல்டிப்ளை பண்ணீங்கன்னா you will get the chemical shift value, that is you will get the coupling constant value. I'll solve the problems and then I'll make it very clear to you people. Okay. Okay, let me take the first problem. In the 400 megahertz proton NMR spectrum of an organic compound, it exhibited a doublet. The two lines of the doublet are at 2.35 and 2.38 ppm. Okay, so the doublets are the doublet are like this. எதுல மெஷர் பண்ணிருக்காங்க? டெல்டா எதுல இருக்கு? ppm ல இருக்கு. ஓகேயா? சோ இப்ப என்ன சொல்றாங்க? The two lines of the doublet ஓட லைன்ஸே சொல்றாங்க. doublet ஓட லைன்ஸ் எங்க இருக்குன்னு சொல்றாங்க? So the doublet line 2.35 and 2.38 சொல்றாங்க. Okay, now if I ask you what is the chemical shift of the proton keta, what will be your answer? First question. If I ask you what is the chemical shift, what will be your answer?
Three hertz.
என்னமா?
3 hertz, ma'am.
புரியல. 3 delta value.
Oh, 0.03, ma'am.
0.03 இல்லப்பா நான் என்ன கேக்குறேன்னா,
2.36.
this is the line of the multiple center point of delta value. This doublet
Okay, average value.
2.36.
average. So 2 points, so ரெண்டுக்கு டிஃபரன்ஸ் பாத்தீங்கன்னா எவ்வளவு வருது? 0.03 வருது இல்லையா? 0.03 வருது இல்லையா? So divided by 2 எவ்வளவு வரும்? 0.015. So center point ஓட வேல்யூ என்ன? What is the value of center point?
மேம் ஆவரேஜ் 2.3 2.35 தானே மேம் நம்ம ஆட் பண்ணி டிவைட் பை 2 போடணும்.
ஆமா நான் அது பண்ணிக்கலாம். இல்லைன்னா என்ன செய்யலாம்? ரெண்டுக்கு டிஃபரன்ஸ் எவ்வளவு? டிஃபரன்ஸ் வச்சு டிஃபரன்ஸ் டிவைட் பை 2 போட்டு இதோட ஆட் பண்ணிக்கலாம் இல்லையா?
எஸ் மேம்.
உங்க சாய்ஸ் தான். 2.38 plus 2.35 எனக்கு கொஞ்சம் tedious தெரியும் எனக்கு, அதனால நான் அப்படி ஈஸியா போயிடுவேன். So 3, so 7, so 4.73 divided by 2 பண்றதுக்கு இது ரெண்டோட டிஃபரன்ஸ் எவ்வளவு? டிஃபரன்ஸ் ரெண்டுக்கும் டிஃபரன்ஸ் 0.03 தானே? So 0.03 divided by 2 எவ்வளவு வரும்? 0.015. So நான் என்ன பண்ணேன்? 2.35 ஓட 0.015 மல்டிப்ளை பண்ணி ஆட் பண்ணிடுவேன். So என்ன வரும்? 2.365. So what is the center point? So what is the chemical shift? 2.365. Do you get the point? This is chemical shift. புரியுதாப்பா எல்லாருக்கும்? Do you understand? What have I done? என்னம்மா? Any doubts?
No, ma'am. No, ma'am.
Yeah. So chemical shift of a particular molecule will be at the center point. So இங்க ரெண்டு லைன்ஸ் ஓட டெல்டா கொடுத்திருக்காங்க. அப்ப chemical shift கேட்டாங்கன்னா அதுல center point கண்டுபிடிக்கணும். So you can go like this. So 2 2s are 4, 2 3s are 6. So then you have 2 6s are 12, 2 5s are 10. எல்லாம் ஒண்ணுதான். They'll get the same answer only. But how you're going to do it? Okay. Now ஆனா இங்க கேட்டிருக்க ப்ராப்ளம் என்ன கேட்டிருக்காங்கன்னா, இந்த ப்ராப்ளம்ல J ஓட வேல்யூ என்னன்னு கேட்டிருக்காங்க. So J ஓட வேல்யூ எப்படி கண்டுபிடிக்கணும்னா ரெண்டு விதமா பண்ணலாம். ஒன்னு, you can multiply this into 400, this into 400, you will get the value in hertz, then minus பண்ணலாம். இல்லனா ரெண்டுக்கு டிஃபரன்ஸ் எவ்வளோ? ரெண்டு டெல்டா வேல்யூக்கு டிஃபரன்ஸ் என்ன? இந்த distance between the lines எவ்வளோ? What is distance between the lines? doubletல லைன்ஸ்க்கு டிஃபரன்ஸ் என்ன? What is the difference between the lines? 0.03 ppm. Agree பண்ணிக்கிறீங்களா எல்லாருமே? Do you all agree?
Yes, ma'am.
Yeah. So now how to convert into hertz? Hertz எப்படி convert பண்றது? 0.03 ppm multiplied by the instrumental frequency in megahertz. மெகாவும் 10 ppm cancel ஆயிரும். Okay. So you'll be having what you will have? So 0.03 into 400. What is the answer?
12 hertz, ma'am.
12. Very good. That's all. பார்க்கதான் ப்ராப்ளம் ரொம்ப டிஃபிகல்ட்டா தெரியும். 4 marks இந்த கொஸ்டினுக்கு. It will look difficult, but it's very simple problem. Okay, so difference between the lines of the multiplets, adjacent lines of the multiplets is what's known as coupling constant. Suppose அவங்க டெல்டால கொடுத்திருந்தாங்கன்னா அந்த டெல்டா வேல்யூவை ஹெர்ட்ஸ் ஆல மல்டிப்ளை பண்ணிடணும், இன்ஸ்ட்ருமெண்டோட மெகா ஹெர்ட்ஸ் ஆல மல்டிப்ளை பண்ணிடணும். So you will get the answer. Is this problem clear, guys, for all of you? Yes? Yes? Yes,
Yes,
or no?
ma'am.
Yeah. So same thing I've done the calculation. So either you can do what you can do delta when you hertz mega instrument or megas multiply you can get the value. This is tedious இல்லையா பண்ணி 2 மைனஸ் பண்ணா 12 வந்துரும் இல்லனா சோ இத நான் மல்டிப்ளை பண்ணிக்கிறேன் இத மல்டிப்ளை பண்ணிக்கிறேன் வந்ததுக்கு அப்புறம் ஹெர்ட்ஸ்ல வந்துரும் வந்ததுக்கு அப்புறம் மைனஸ் பண்ணிக்கிறேன் இல்லனா ரெண்டையும் சப்ட்ராக்ட் பண்ணி வர்ற ppm மல்டிப்ளை பை 400 you'll get 12 hertz. So உங்களுக்கு எது ஈஸியோ you can go by that. Okay. Now let me see how you people are doing this. இது எப்படி பண்றீங்க நானும் பார்க்கிறேன். ஆனா ரொம்ப சிம்பிள் ப்ராப்ளம் ஒரு சின்ன க்ளூலயே ஆன்சர் கண்டுபிடிச்சிடலாம். AX3 சரியா? So type proton type is AX3. AX3 என்னன்னா you have an hydrogen A hydrogen and neighboring you have 3 different hydrogens X hydrogens. Now this AX, there was Poppel notation, so we need not know all that. இப்போ நம்மளுக்கு தேவையில்லை Poppel notation, spin system அதெல்லாம் தேவையில்லை அதனால I'm not going to discuss about all that. But இது AX3 system. So AX3 systemல A பக்கத்துல எத்தனை protons இருக்கு? How many protons near A? A has 3 neighboring protons. So what will be the splitting pattern of A? A எப்படி split ஆகும்?
Quadrant.
Quartet. Okay, so A will be split as a quartet. What about X? X பக்கத்துல neighboring எத்தனை proton இருக்கு? I have only one proton, therefore X will be split as a
Doublet.
doublet. Okay. இப்போ என்ன சொல்லிருக்காங்கன்னா X proton ஓட value 2.1 2.3 delta value. A க்கு என்ன கொடுத்திருக்காங்க? A is given as 4.1 4.3 4.5 and 4.7. Okay, now can anyone tell me what is the chemical shift of this is A, this is X. Maybe I have got a clear picture. Now this is given as X, this is X and this is A. Okay, X is given as 2.1 and 2.3. A is given as 4.1 4.3 4.5 4.7. Could anyone tell me what is the chemical shift of A and chemical shift of X? X oda chemical shift enna, delta value enna? What is the delta?
2.2 ma'am.
2.2. Very good. What about A? A
4.2.
Okay. இதுல என்ன வந்துச்சு ஆன்சர் கண்டுபிடிச்சிடலாமா? A is 4.4, X is 2.2. எது ஆன்சர்? What is the answer? A is 4. A அவ்வளவுதான் முடிஞ்சு போச்சு. எல்லாமே தப்பு, மிச்சம் எல்லாமே தப்பு. நம்ம straight away we have got the answer. புரியுதா? Suppose they have given another option which contains 4.4 and 2.2. Suppose இங்கே கொடுத்திருக்காங்க. For example, this is given as 4.4, 2.2 and 10 is given. Now you have a choice. இப்போ நீங்க கண்டுபிடிக்கணும். So நம்ம third option போவோம், that is the coupling constant value. Now what is coupling constant value? Coupling constant value is the difference between the lines of the spectrum. எவ்வளவு தூரம் A X ஓட couple ஆகுதோ அதே X A ஓட couple ஆகும். So this difference between lines, what is the difference between the lines? How many delta? How many ppm?
0.2 ma'am.
0.2. It is given in what? It's given ppm. How to convert to hertz? இது hertz எப்படி மாத்துறது?
into 100 ma'am.
Into 100. 100 எங்க இருந்து வந்துச்சு? Operating frequency 100 megahertz. So 0.2 into 100 is equal to what? 20. So what is the answer? Option A. புரியுதா? Suppose உங்களுக்கு ஆப்ஷன்ஸ்ல கன்ஃபியூஷன் இருக்கு. இது 4 மார்க்ஸ். ஆப்ஷன்ல கன்ஃபியூஷன் இருக்கு. 4.4 2.2 20 கொடுத்திருக்காங்க. 10 கொடுத்திருக்காங்க. என்ன செய்வீங்க டக்குன்னு? The difference between lines எடுத்துட்டு into 2 into 100 operating frequency போட்டீங்கன்னா in megahertz போட்டீங்கன்னா you'll get the answer. Is this type of problems clear to you? Is the types of problem clear? Is this clear,
Yes,
guys? Yes. Okay. So now let me see how much it is clear to you. So இத நான் solve பண்ணி வச்சிருக்கேன் ஒண்ணும் இல்ல. Okay. Okay. Now tell me this. The C13 spectrum of acetone has a signal at 30 ppm as a septet. In the intensity ratio. ரொம்ப சிம்பிள் தான். இன்டென்சிட்டி ரேஷியோ என்னவா இருக்கும்? இப்படி இருக்க நீங்க ஸ்ட்ரெயிட்டாவே பார்க்கலாம். ஒரு செப்டெட்னா 7 சிக்னல்ஸ். 7 சிக்னல்ஸ்னா 1 2 3 5 இப்படி எல்லாம் கூட வாய். So this is all are wrong. நம்ம பார்த்திருக்கோம் இல்லையா பாஸ்கல்ஸ் ட்ரையாங்கிள். So இந்த இவ்வளவு கம்மியா இன்க்ரீஸே ஆகாது. Okay, so you know this, இல்லையா? So you can always know. So Pascal's triangles, as we have seen, you'll be having, see, it is increasing. In a traditional or by increase down. So you'll be having 1, 5, 10, 10, 5, 1 for sextet, and 1, 6, 15, 20, 15, 6, 1 for septet. So answer is option A. Now my question is, they are saying acetone D6. Acetone D6. Now they have said that acetone D6 gives a septet. Now suppose இது கேட்டிருக்காங்க acetone D6 ல what is the multiplicity of carbon கேட்டா என்ன, how will you calculate? Acetone 7 எப்படி கண்டுபிடிச்சீங்க? 7 எப்படி வந்துச்சு? How did you get the 7? How did you get the 7? So this problem you know, but if a problem with unknown is given, so hydrogen when it is replaced by deuterium, how will you say that you get 7?
2ni plus 1 formula, ma'am.
Very good. Yeah, 2ni plus 1 formula. Now tell me, suppose I have hydrogen. Suppose I have hydrogen. What will be the multiplicity of carbon? Hydrogen and the multiplicity எப்படி இருக்கும்? So in CH3 neighboring how many hydrogens? Same rule. Directly attached hydrogens எத்தனை இருக்கு CH3 ல? Did we study the multiplicity of carbons? Yes, we have already seen, is it not?
Yes, ma'am.
Carbon will couple with only its directly attached protons. That is why we are going for off resonance decoupling, ORD. Broadband decoupling, all the hydrogens will be excited, decoupled, therefore you'll be having only singlets for each carbon. But when I talk about off resonance decoupling, the carbon will couple with its own hydrogens. So 3 hydrogens, therefore carbon will be n plus 1. So 3 plus 1. So it will be quartet. Okay, so இதே நான் 2ni plus 1 போட்டா எப்படி போடுவேன்? 2ni plus 1. So 2 into neighboring 3 protons. Each proton, hydrogen has, what is the I value of hydrogen, guys? What is the I value of hydrogen?
1 by 2, ma'am.
1 by 2, very good. So 2 will cancel. So I'll be having 3 plus 1, which will be equal to 4. சரி அதேதான். So 2ni plus 1 formula தான். But நம்ம என்ன சொல்றோம்? இந்த I is for hydrogens, I is equal to half. Half and 2 cancel ஆதான் என்ன சொல்றோம்? N plus 1 formula சொல்றோம். N plus 1 சொல்றோம் formula because I is equal to half, I equal to half and the 2 cancel ஆயிரும். So automatically N plus 1 formula வந்துரும் நம்மளுக்கு. அதனால புரோட்டான்லயும் கார்பன்லயும் you use the N plus 1 rule. N plus 1 rule. And but really this is the formula 2ni plus 1. So carbon 3 protons attached now, 3 plus 1 quartet. 2 hydrogens attached now, 2 plus 1 triplet. So when I talk about a quaternary carbon, n plus 1, you'll be having 0 plus 1, it will be a singlet. So quaternary carbon will be singlet. You have methane carbon. Methane carbon will be doublet. Methylene carbon will be triplet. And the methyl carbon will be quartet. Okay, so this is a trend, n plus 1 rule. ஆனா இங்க கேட்டிருக்கிறது deuterium. So இங்க அதே 2n plus I plus formula use பண்ணீங்கன்னா for deuterium I is equal to 1. Okay, so what will happen? 2 into 3 into 1 plus 1. So what will happen? 6 plus 1, which will be equal to 7. அதான் septet வருது. Guys, now you understand this. இது ஏன் 7 வந்துச்சு கண்டுபிடிச்சிட்டீங்களா? Have you understood? Yes or no?
Yes, ma'am.
Yeah. சரியா? So இப்படிதான் பார்க்கணும். So you should know how we are getting the answer. Just தெரிஞ்சா மனப்பாடம் பண்ணிலாம் எதுவுமே செய்வேனா. You understand the problem, how we are approaching. So ஹைட்ரஜனுக்கும் அதே ரூல் தான். ஆனா அந்த ரூல் சிம்பிளிஃபை ஆயிடுது. ஏன் சிம்பிளிஃபை ஆயிடுது? பிகாஸ் ஹைட்ரஜனுக்கு I வேல்யூ ஹாஃப்னால சிம்பிளிஃபை n plus 1 வந்துருது. அப்ப deuterium கேட்டா அந்த simplify பண்ண முடியாது நானு. I cannot simplify that. So in that case, you have to substitute the value of I. So from substitution, I get the value equal to 7. Okay. So answer is 1:6:15, 20, 15, 6, 1. Okay. Okay. Now tell me this. Proton NMR spectrum of an organic compound recorded on a 500 megahertz spectrometer showed a quartet with line position at 1759, 1753 and all that. Chemical shift and coupling constant. நீங்க தான் சொல்ல போறீங்க. You tell me what is the answer. What is the chemical shift and coupling constant? I'll give you the quartet கொடுத்துட்டேன். Okay, quartetல என்ன value? 1741, 1747, 1753, 1759. So first என்ன கேட்டிருக்காங்க? Chemical shift கேட்டிருக்காங்க. Chemical shift கேட்டிருக்காங்க. So what is the center value? All that is given in hertz ல கொடுத்திருக்காங்க. These all are in hertz.
Ma'am.
What is center value? So 1753 plus 1747 divided by 2. Or ரெண்டுக்கு difference பாத்தீங்கன்னா it is 6. So 6 divided by 2 is 3. So 1747 plus 3 is 1750. Center point is 1750. Guys, are you listening to me? Yes?
Yes, ma'am.
Yeah.
Yes, ma'am.
So now I have got the value in hertz, but I want the value in delta. ppm ல வேணும் எனக்கு. hertz ல கொடுத்தா ppm எப்படி மாத்துறது?
Divided by
ppm ல என்னமா?
Operation reverse.
By multiply பண்ணுமா divide பண்ணுமா?
divide பண்ணணுமா?
Divide, ma'am.
Divide, very good. So 1750 divided by the frequency of the operating frequency in megahertz, because this is in hertz, this is in megahertz. Cancel, I'll be having 10 power minus 6 to ppm. So what is the answer?
3.5 ma'am.
3.5. Okay, so I've got two options. So 3.6 cancel, 3.6 cancel. So 3.5. Now the next is, what is the coupling constant? இங்க நான் multiplication பண்ண வேணாம், ஈஸியா கண்டுபிடிச்சிடலாம். What is the coupling constant? Coupling, yeah, coupling constant is the distance between the lines of the multiplets. So 1747 minus 1741 is 6 hertz. Already answer எதுல இருக்கு? ஹர்ட்ஸ்ல தான் இருக்கு. So நான் ஏதாவது மல்டிப்ளை பண்ணுமா, டிவைட் பண்ணுமா, ஏதாச்சும் பண்ணுமா? Should I do anything?
No, ma'am.
No. So answer is 6 hertz. So coupling constant. So straight away we have got the answer. 3.5 ppm and 6 hertz. Problem easy ஆகல இந்த மாதிரி problems? ஹர்ட்ஸ்ல பண்றது. Is this easy for you people?
Yes, ma'am.
Yes, okay. Now, one last question. So நான் சொல்லி கொடுக்கிறது, I've just done it on the scale. I've done it already for you people. Okay. Okay, now tell me this very interesting problem. Give me the final answer. Then we will discuss. Yeah, tell me guys. You're taking a long time. Very interesting problem.
Coupling constant 30 hertz, ma'am.
Coupling constant 30 hertz. எப்படிப்பா?
200 megahertz க்கு 2 ppm போட்டுருக்கு மேம். அப்போ 600 க்கு வந்து into 3 ஆ பண்ணிருக்கோம்னா 30 hertz வரும்.
So doublet separated by 2 ppm. நல்லா ஞாபகம் வச்சுக்கோங்க. Coupling constant is independent of the instrument.
Option D.
Operating frequency of instrument. Keep this in mind. So நல்லா ஞாபகம் வச்சுக்கோங்க. சில விஷயங்கள் மாறாது. Coupling constant is independent of the mega operating frequency of the instrument. Whatever instrument you record, the multiplicity with the coupling constant, the distance between the lines of multiplex will not change. The distance between the lines of the multiplex will not change. So the coupling constant is independent of the have you understood, ma? What am I saying? Coupling constant instrument மாறதுனால coupling constant value மாறாது. அப்ப எது ரெண்டு நீ ரூல் அவுட் பண்ணிடலாம்?
Option 1 and 2.
1 and 2 முடிஞ்சு. ஓகே. சோ 3 and 4ல தான் ஏதோ ஒரு ஆன்சர் இருக்கு. இப்போ என்ன
4 is
சொல்றாங்கன்னா
ஆப்ஷன் டி
4. ஆப்ஷன் 3. ஆப்ஷன் 3 ஆப்ஷன் 4
option 4 ma'am.
சோ இது கரெக்ட், இது கரெக்ட். சரி, ஆப்ஷன் 3 சொன்னது யாரு? Who told me option 3?
3 ன்னு சொல்ல டி.
How did you get 600, ma?
ஆப்ஷன் டி ன்னு சொன்னோம் மேம்.
Option D ன்னு சொன்னீங்க, option 4 ன்னு சொன்னீங்க. ஓகே, ஒண்ணுமே இல்ல. We know that delta is equal to the separation, that is the separation in hertz, that is delta nu. Delta nu by nu in megahertz. சரியா? So, இப்ப delta value நல்லா ஞாபகம் வச்சுக்கோங்க. delta value and J value, they are independent of the operating frequency of the instrument. எந்த இன்ஸ்ட்ருமெண்ட்ல ரெக்கார்ட் பண்ணாலும் chemical shift value மாறாது, coupling constant value மாறவே மாறாது. So delta value மாறாது. Okay, so this 2 is going to remain constant. So they are doublets separated by 2 ppm na, and the ppm value மாறவே மாறாது. So this 2 is going to remain constant, but the operating frequency is changing. So for example, if I am having 200 megahertz instrument, in order to have 2, what should be in the numerator? Numerator என்ன இருக்கணும்?
400.
400. So the line should be separated by 400 hertz so that I have 2. So similarly, if I take a 600 megahertz instrument, the 2 will not change. The ppm between the lines will never change. Coupling constant will never change. Okay. So what should be the difference in the lines of the spectrum? Enna irukonu inga difference enna irukonu? Lines of the spectrum. 2 varnuna inga mela enna irukonu? If I want to have 2, what should be the numerator?
1200.
Okay, so just keep in mind. So எனக்கு ஒரு doublet வருது. Doublet ஓட delta value என்ன சொல்றாங்க? Separation is 2 ppm னு சொல்றாங்க. 2 ppm separation. So if this distance which is known as the coupling constant of the protons, that will always remain constant. 10 hertz na 10 hertz. அவ்வளவுதான். That will not change at all. That will never change. Okay. For example, if I have, this is operating. So suppose it is operating at 200 megahertz instrument, they'll be separated by 400 hertz. Okay. So difference எப்பவுமே 10ல தான் இருக்கும். Difference will be always in 10 hertz தான் இருக்கும். சரியா? So 410 na 420 அவ்வளவுதான். So that difference between the separation between the lines of the spectrum will always remain same. Coupling constant will always remain same. என்ன வித்தியாசம் வரும்னா, ஒரு இன்ஸ்ட்ருமெண்ட்ல ரெக்கார்ட் பண்றப்ப அந்த லைன்ஸோட செப்பரேஷன் மாறும், பட் the multiplexோட செப்பரேஷன் மாறவே மாறாது. That will always remain same. That will always remain same. That you should keep in mind. Okay, never forget that the difference between the distance between the lines of the multiplex is always same. The coupling constant will never change, and not only that, the chemical shift values is also independent of the operating frequency. That will also never change. அது மாறவே மாறாது. Okay, so 2 na 2 தான் இருக்கும். 2 na 2 தான் இருக்கும். அவ்வளவுதான். That will never change. Okay, so since I'm having 2, what they're asking, the separation between these two signals and the coupling constant. So 600 megahertz இப்படி இருக்கும், 400 megahertz இப்படி இருக்கும். That is the only change which you can observe. Okay. So they say that 2 doublets separated by 2 ppm. So ரெண்டு doublet இருக்கு, ரெண்டு doublet இருக்கு. ரெண்டு doublet என்ன ppm. So this is, suppose for example, this is coming at 2 ppm, this is coming at 4 ppm. The distance between, so இதுக்கு ரெண்டுக்கு நடுவுல இருக்கிற distance 2 ppm னு சொல்லிருக்காங்க. சரியா? So இந்த 2 ppm என்ன ஆகும், இந்த டிஸ்டன்ஸ் என்ன ஆகும். நார்மலி ஒரு ஹையர் வெர்ஷன் இன்ஸ்ட்ருமெண்ட் போறப்ப the multiplets or distance கூடும். ஃபார் எக்ஸாம்பிள் ஒரு 200 மெகாஸ் இன்ஸ்ட்ருமெண்ட்ல they'll be separated by 400 hertz. அதே இது 600 மெகாஸ் இன்ஸ்ட்ருமெண்ட் they'll be separated by 1200 hertz. அதான் டிஃபரன்ஸ். சோ ஒரு டப்லெட் இருக்கு. So suppose I have a doublet. Okay, so in a 200 megas instrument they are separated by 400 hertz, whereas in a 600 megas instrument multiplets will be like this. So this distance will be 1200. Avloda difference. So enna that this is known as simplification of complex spectrum. Normally na megas கூட்டிட்டே போக when I increase the megas of the instrument, the multiplets get separated. So you will be having, suppose or complex இருக்கு, all the multiplets are lying over one another, they are coalescing. So என்ன ஆகும்னா ஒரு first order spectrum second order மாறிடும், very complex spectrum சொல்லுவோம். So அந்த மாதிரி spectrum solve பண்ணனும்னா one way of doing is that by increasing the operating frequency, that is I increase the operating field. Okay, so I'll be operating at a higher field or higher megahertz. So இதுல பாத்தீங்கன்னா அந்த delta value மாறாது. In the separation, the lines நடுவுல இருக்க separation will remain the same. இங்கேயும் 10 hertz separation தான், இதுவும் 10 hertz தான். அது மாறவே மாறாது. Is this clear? Multiplets, distance between the lines of multiplets will not change, never change. என்ன மாறும், multiplets தள்ளி போற distance தான் மாறும். This is what is going to change. The difference. So two doublets, ரெண்டு வேற வேற doublet 200 megas instrumentல 400 hertz தள்ளி இருக்குனா, அதே ஒரு 600 megas instrumentல 1200 hertz தள்ளி இருக்கும். Is this point clear? Is this clear? Yes?
Yes, yes.
So answer is option D. So those who have not understood in the previously, now you just keep this in mind. Okay, so coupling constant value மாறாது, chemical shift values எப்பவுமே மாறவே மாறாது. என்ன மாற்றம் இருக்க போது, the distance between the peaks can change. Okay, that alone can change. So that is why the spectrum becomes clearer and clearer when you operate at a higher frequency. Okay, the C13 NMR spectrum of DMSO D6 gives a signal at 39.7 ppm as a what? What is DMSO?
Dimethyl.
Yeah, dimethyl. Yeah, correct.
Dimethyl sulfoxide.
Sulfoxide.
Dimethyl sulfoxide. The CD3. CD.
English.
This will give you what they are asking. So yeah, whereas carbon could get carbon na they same formula 2 and 2 plus 1. So you'll be having 2 into number of deuterium 3, I value is equal to 1 plus 1. So you'll be having 7. So what is the answer? Septet. Is that okay? Yes? Yes, ma, all of you?
Ma'am.
Yeah. Okay. Okay, now one more thing. That's already I've mentioned this, but again, one more time I'll say there's something known as dynamic and static equilibrium. So normally the OH protons are in constant equilibrium with the solvent protons or with their own protons. So they'll be constantly moving away from each. They'll be constantly in motion. Okay, so since they are constantly in they are not staying in one place, that is they are constantly in equilibrium with their solvent protons or they are with the their own protons, that is oral alcohol, inner alcohol, they are just constant motion. Okay, so they are rapidly exchanging. So in such cases what happens, the spin information of such hydrogens cannot be recorded by the neighboring protons. So பக்கத்துல இருக்க protons ஆல அந்த OH protons ஓட couple ஆகவே முடியாது. சரியா, ஏன்னா அது ஒரு இடத்துல நிக்கணும். So in order to get the coupling information, the OH protons should stay at one place, but it is not staying, it is rapidly exchanging between the molecules. Okay, so what happens in this such case is that the OH protons will never couple with the neighboring protons. Okay, so this is obviously the cases for the exchangeable protons. So OH protons, NH protons will never couple with the neighboring protons. So that keep in mind, okay? Okay. So this is all we have seen, the doublets, all that we have seen, okay? Now, coming to the problems. So now we'll be having completely the bigger problems, okay? The organic compound that displays following data. Straight away ரெண்டு ஒரு ஆப்ஷன் straight away தூக்கிடலாம். எந்த ஆப்ஷன் தூக்கிடலாம்? Straight away ஒரு ஆப்ஷன் தூக்கிடலாம். எது?
Option 4.
Very good. Option 4 straight away தூக்கிடலாம். Why? Because you have doublet and doublet. So doublet and doublet nala I can straight away, because aromatic region aromatic region, doublet and doublet, therefore it is para substituted. So I can straight away rule out the meta option. Okay, then next what? There are totally only aromatic region para substituted, therefore will be having this will be this. So this and this and this and this. அவ்வளவுதான். அதுக்கடுத்து அலிஃபேட்டிக் ரீஜன்ல ஒரே ஒரு சிக்னல் தான் இருக்கு. இப்போ இந்த ப்ராப்ளம் பார்த்தோம், this will give you one signal, this will give you one signal. So இங்க you will be having totally 4 proton NMR signals. Here you have one signal, here you have so 1, இது ஒரு 2, இது ஒரு 3, இது ஒரு 4, இது ஒரு 5. So 5 proton NMR signals. So this is also not the answer. This is also wrong. So this will give you one signal, this will give you second signal, and all these protons will give you one signal. So totally you have 3 signals. So moon signal now, that is possible only for the option 1. Do you get the answer, guys? Do you understand?
Yes, ma'am.
Yes, ma'am.
The answer is option 1. Now values, I have not looked into values also. Now values kuda paakla. Values paakamle number of signals vachi enna panila, I can rule out the option 2nd and 3rd. Okay. Okay.
Option A, ma'am.
Option A. Option A, 1, option 1. Any other answer? Any other answer? Yeah, guys, come on. Did the IR value help you? IR value help பண்ணுச்சா? What information you get from IR spectrum? You get the information about?
Functional group.
Okay, now it tells you about functional group. So what information did you get from IR?
It should be keto group.
Yeah. So if I have an ester, so I have a keto group here, I have a keto group here, and I have an ester group here. I have an ester group here. Okay. So when I have an ester will usually around 1750. Suppose conjugation now it will be around 1735 or 1725 something, but it cannot go till 1690. So ester 1690 and ester irukka vaipe illa. So IR vachi enna pannirren 2 and 4 rule out pannidalam easy-a. Now I have an idea. Okay, ketone irukla enakku idea irukku. Nalla guys, nalla ஞாபகிச்சுக்கோங்க, நம்ம ரொம்ப யோசிக்கவே வேணாம். எல்லா ப்ராப்ளம்ஸ்லயும் ட்ரிக்ஸ் தான் இருக்கு. There are a lot of tricks in the problem to easily solve it. ரொம்ப தூரம் வேல்யூஸை பார்த்து சால்வ் பண்றதுக்கு நமக்கு அந்த சான்ஸே தேவைப்படாது. Simply based on certain tricks you can easily solve it. So IR வச்சு 2nd and 4 rule out பண்ணிறேன். Then I see that in proton நம்ம 6.9 doublet, 7.8 doublet. Doublet and doublet என்ன அர்த்தம்? 2 hydrogen doublet, 2 hydrogen doublet.
Para substitution.
Para substitution. So para substitution எதை rule out பண்ணிடலாம்? Which one can I rule? So இப்ப ketone தான் தெரியும், but எதை rule out பண்ணிடலாம் paraனால?
3, ma'am.
3 முடிஞ்சு அப்ப என்ன answer? What is the answer? 1. Did I just look into the each and every value na paatena? Did I look into each and every value? No, that is not required at all. That is not required at all. The only one thing which is misleading maybe, or you can have confusion, is 197. Generally what you say is when you have a ketone, you will be having about 200. But reason why this ketone is so much shielded, ஏன் இவ்வளவு ஷீல்டிங்கா இருக்கு 197? நார்மலி கீட்டோன் என்ன வேல்யூ வரணும்? கீட்டோன் கார்பன் என்ன வேல்யூ வரணும்?
200 and 400.
200 and above, but 197 ஏன் இது 197 இருக்கு? Because you have electron donating group para. So it will give you the electrons, you will be having a negative charge here. So it will be shielded, the carbon will be shielded. So அதனால கொஞ்சம் value குறையுது. Okay, otherwise ketone carbon will usually be around 200. Okay, 200 and above. Now look here guys, நான் எதுவுமே பண்ணலனா without looking into the data, based on the simple logical and tricks I have solved this problem. So IR vachu I say that's not a ketone, so it's not an ester. I rule out option 2 and 4, and based on the proton doublet and doublet I say it's a para substitution, so I rule out the meta substitution. Very simple. Suppose I look into the values 3.8, so the methyl attached to oxygen will be 3.8, and the 3 hydrogen singlet, so this is also singlet because they don't have neighboring protons, so this CH3 will be around 2.5. அதுக்கடுத்து நான் வேணா யோசிச்சுக்கலாம். And 6.9 and 7.8, so if plus R group, therefore these hydrogens are at 6.9, and since this is minus R group, this hydrogen will be around 7.8. Everything is suitably fitting, ellame correct fit agudhu, so this is the right answer. Option 1 is the right answer. Is this okay guys for all of you? Yes?
Yes, ma'am.
Okay. Okay, so ketone values எல்லாமே discuss பண்ணிருக்காங்க சரியா? So இங்க ketone normally 1710 வரணும், but whenever you have a conjugation, so C double bond O is in conjugation, so whenever you have a conjugation, what will happen? C double bond O character will change to C single bond O character, therefore the vibrational frequency will decrease. That is why the ketone reduces to 1690. Is that okay? Okay, so conjugation நால ketone value குறையுது, 16 குறையுது, and ester value அவ்வளவு தூரம் குறையிறதுக்கு வாய்ப்பே இல்லை. Okay, so that is how I find it out. Now tell me, கொஞ்சம் டஃப்பான ப்ராப்ளம் தான், பட் பண்ணிடலாம். Yeah, tell me guys.
Option B, ma'am.
Option D. D or B?
Option 2.
2. Option 2. How you say 2? Could you explain your answer?
From the value 3.80, methyl group is attached to oxygen, ma'am.
Okay.
So
So
we
in
can do
all
it.
cases, so you can rule out this. Ilya?
Yes, ma'am.
So this cannot be answered. So here also you have OME, here also you have OME. So I have 1, 2, 3 left out. Now tell me, yeah. Okay. Then. Very good. Correctly approaching. Tell me next.
Next one is from the value 7.75, actually double doublet they have given, ma'am.
Okay.
So between nitro and methoxy group, because nitro is electron withdrawing group, ma'am.
Okay.
So the value must be 7.58.
So you're saying this one.
Yes, ma'am, because it is that they have given. So it will couple with only one hydrogen that is nearer to NO2.
Okay.
And the other two are double doublet, ma'am.
Okay, what is the doublet of doublet, all that stuff? What is the doublet of doublet? What is this DD, doublet of doublet? DD. Doublet of doublet.
மேம் ஆப்ஷன் 3 இல்லையா மேம்?
ஆப்ஷன் 3 இல்லையான்னு என்கிட்ட கேக்குறீங்களா?
மேம் ஏன்னா அதுல மீத்தாக்சி குரூப்புக்கு எதிர இருக்கிற அந்த ஹைட்ரஜன் வந்து 2 ஹைட்ரஜனும் அஃபெக்ட் பண்ணும் மேம். ஃபர்ஸ்ட் ஒரு ஹைட்ரஜன் தனியா டப்லெட்டா ஸ்ப்ளிட் பண்ணா அடுத்து இன்னொரு ஹைட்ரஜன் டப்லெட்டா ஸ்ப்ளிட் பண்ணும். அப்ப ஆப்ஷன் சி தானே மேம் வரும்.
Okay. So contemplating things, I'm very happy you're answering to me. எனக்கு first சந்தோஷம். தப்போ ரைட்டோ நீங்க you are opening your mouth, I'm very happy about it. Okay. Now இதுல first அவங்க அழகா சொன்னாங்க. So 3.8 singlet 3 hydrogens. So the hydrogens CH3 had attached to oxygen. So இப்படி இருக்கணும் சரியா? So அதை பேஸ் பண்ணி நான் 4 ரூல் பண்ணிட்டேன். இது எல்லாருக்கும் ஓகேவா? இது எல்லாருக்கும் ஓகேவா? Is this okay to everyone?
Yes, ma'am.
Yes, okay. அடுத்து பாத்தீங்கன்னா you have doublet of doublet, you have a doublet, you have a doublet, and aromatic region you have a singlet. Aromatic sorry, you have 6.50 broad singlet, 2 hydrogens. Not aromatic region, singlet, 2 hydrogens. What is the singlet, 2 hydrogens?
NH2.
Why you have singlet? That is NH2. Okay, so I have an NH2. So inge NH2 irukku, inge NH2 irukku, inge NH2 irukku. சரியா? Now you can see that the coupling constant value 8.8, 2.4. You have here 2.4, here you have 8.8. சரியா? So இப்ப நீங்க எப்படி சொன்னீங்க இது? So this is hydrogen, hydrogen, hydrogen. Normally நம்ம இப்ப aromaticல நான் அதை டிஸ்கஸ் பண்ணிடுறேன் உங்கள்ட்ட, அப்பதான் உங்களுக்கு புரியும். சரியா? Suppose I have this hydrogen. This hydrogen, suppose I have a different moment. This is coupling with orthoproton, metaproton, paraproton. Suppose you have different environment, okay? So இது வேற proton. So எப்பவுமே orthoproton Wisnal coupling. இதுக்கு பேர் Wisnal coupling, 3J coupling. 3J coupling will be having a value of around 6 to 8. Okay, so around 8 hertz. 6 to 8 hertz குள்ள இருக்கும். I can go to 8, அவ்வளவுதான். 6 to 8 or 8 to 9, 8.5 something. So இந்த hertz குள்ள தான் இருக்கும். அதே இது, this hydrogen coupling with metaprotons. This is known as 4J coupling. Long range coupling. This will be having a value of around 2 to 3 hertz. And this hydrogen coupling with the paraprotons. Again a long range coupling. This 5J coupling. And this 5J coupling will be having a value of 0 to 1 hertz. ரொம்ப கம்மியான coupling. Distance கூட coupling information ரொம்ப தூரமா போயிடுது. So coupling information will be lost. So will be having very low coupling. So as the distance increases. So ortho coupling or 3J coupling, higher value. Meta coupling, then you'll be having the para coupling. Suppose I take here, இது இதோட couple ஆகுது, doublet. திரும்பி இதோட couple ஆகுது, doublet. So they all are Wisnal coupling. So Wisnal coupling la value 2.4 இருக்கிறதுக்கு வாய்ப்பே இல்ல. Did you get this point, ma? So 2.4 na, இது ரெண்டுமே Wisnal coupling தான். Wisnal coupling la 2.4 வரதுக்கு வாய்ப்பே இல்ல. Do you get this point? Yes or no?
Yes, ma'am.
அப்ப இது இதோட couple ஆகிறதுக்கு suppose இது couple doublet, இது திரும்ப இதோட couple ஆனதுக்கு அப்புறம் this doublets are split into doublets. So what is this doublet of doublet? First ஒரு doublet form ஆகுது. ஒரு doublet form ஆகுது. Then இன்னொரு neighboring proton திரும்ப அதை split பண்ணும். So that becomes your doublet of, so this will be further split into doublet. Doublet of doublet னு சொல்லுவோம். இதை doublet of doublet. So doublets of doublets. So first you'll be having a splitting by a neighboring proton to give you a doublet. Then a different neighboring proton splits the doublet into doublet of doublet. This is possible only when the coupling constant, that is the chemical shift of the two different protons, are very different in nature. So they can do further splitting. So ஒரு ஸ்டாண்டர்டா ஒரு refined instrumentல இந்த மாதிரி பார்க்க முடியும். Suppose I take a 100 megas instrument, இந்த மாதிரி doublets or triplets எல்லாம் பார்க்கவே முடியாது. So when you have a very refined, highly operating instrument, higher operating frequency instrument, in the mind you can see doublets or doublets, triplets or doublets or triplets, இதெல்லாம் பார்க்க முடியும். சரியா? So first ஒரு splitting followed by further splitting. ஆனா இங்க என்ன சொல்லிருக்காங்க, ஒரு doublet 8.8ல இருக்கு, இன்னொரு doublet 2.4ல இருக்கு. So ஒரு coupling 8.8, இன்னொரு coupling 2.4 னா one is your 3J coupling, the other one is 4J coupling. இது agree பண்ணிக்கிறீங்களா? Do you agree with this?
Yes.
Okay. So அதை பேஸ் பண்ணா என்ன ஆயிரும், எனக்கு option 3 என்ன பண்ணிடலாம்? I can rule out option 3. Do you get the point? Yes or no? Yes or no, ma?
Yes, ma'am.
Yeah. So now you can see that you have three sets of protons. One is 7.75, one is 7.58, the other one is 6.70. So 7.75 and 6.70, they have a coupling of 8.8. In the problem, konja tough than, but try to listen to what I'm saying. So 7.75 க்கும் 7.75 க்கும் 6.70 க்கு நடுவுல இருக்க coupling constant 8.8. Therefore, they are 3J coupled. இது agree பண்ணிக்கிறீங்களா? Do you agree? Yes,
Yes, ma'am.
do you agree? Yeah. So they should be ortho to each other. Okay. So in the protons, so this should be 7.75. This should be 7.58. இந்த மாதிரி இருக்கணும். There should be something like this. Do you get the point? Yes? Yes or no?
Yes, ma'am.
Yeah. And இன்னொரு proton 7.58 கொடுத்திருக்காங்க. So இது ரெண்டுமே, so இது suppose 7.75, இது 6.70, 6.70. So the 8.8 coupling, 3J coupling எனக்கு எங்க இருக்கு? 6.70 7.75 இருக்கு. So 3J coupling, இதுதான் 3J coupling. 7.75 6.70 3J coupling. அப்ப இந்த leftover proton ஓட value என்ன? It should be 7.58. This proton cannot be 7.58 because it is flanked by 2 electron donating group. So only this can have a value of 7.58. இப்படிதான் approach பண்ணும். Guys, are you following? நல்லா பாருங்க. So 8.8, the coupling protons, 3J coupling protons. So இதை நம்ம rule out பண்ணிட்டோம் based on this. இதை rule out பண்ணிட்டோம் based on saying that you have a coupling which is 3J coupling and 4J coupling. இதுல 3J coupling 4J coupling வரதுக்கு வாய்ப்பில்லை because the central protons has both the protons which are vicinal to it. Okay, so I go for 1 and 2. 1 and 2, if I take these hydrogens, they are the 3J coupling protons, 8.8. So this should be attached to a nitro பக்கத்துல இருக்கனால 7.75. இது NH2 பக்கத்துல இருக்கனால 6.70. அதே மாதிரி இது 7.75, 6.70. இது வரைக்கும் எனக்கு ஓகேவா இருக்கு. ஆனா அந்த remaining one proton 2.4, that is, it is having 3J coupling. 3J coupling with your 7.75. 4J coupling with 7.75. அது இங்கே தான் possibility இருக்கு 4J coupling க்கு. அது இங்கே வந்துச்சுனா that becomes 5J coupling. 5J coupling na it will be having still lower value. அத பேஸ் பண்ணி ரூல் அவுட் பண்ணிக்கலாம். இல்லனா this should have a value of 7.58, which is not possible because it is having OMe plus R group, NH2 plus R group. ரெண்டுமே plus R group நடுவுல இருக்கிற proton இவ்ளோ டீஷீல்டிங் வாய்ப்பே இல்ல. So this should be 7.58, which is attached to a nitro or ortho to nitro. Okay, 7.58. Not only that, and these two are having 3J coupling information. Sorry, 4J coupling information. 4J coupling. 4J coupling will be around 2 to 3 hertz, whereas this is having 5J coupling, which will be having a value of 0 to 1 hertz. 0 to 1 hertz. So இது possibility இல்ல, one possibility. So 2 should be the answer. 2 should be the answer. Is this clear, guys? கொஞ்சம் tough தான், I can understand, but you can always solve it. Is this okay to all of you?
Yes, ma'am.
Yes, ma'am.
Okay. Coming to this problem. போக போக எல்லாமே tougher problems தான் இருக்கும்.
Option A, ma'am.
Option A. How? Tell me, ma, how you have approached?
மேம் இங்கேயும் மீதாக்சி குரூப் இருக்கு மேம். ஸோ ஆப்ஷன் 4 வந்து ரூல் அவுட் பண்ணிடலாம் மேம்.
என்னமா?
இங்கே வேல்யூ வந்து நமக்கு 3.8 கொடுத்துருக்காங்க மேம். ஸோ ஆப்ஷன் 4 வந்து ரூல் அவுட் பண்ணிடலாம்.
3.8, 3 hydrogen singlet. Okay, so you can rule out option 4 because this methyl attached to a double bond alkene பக்கத்துல இருக்க methyl 2 to 3 கிட்ட வரணும். Methyl attached to benzene should be also around 2 to 3. Very good. So the base பண்ணி 4 rule out பண்ணிடு. Okay, what else?
தென் இது வந்து
What else?
டிரான்ஸ் தான் மேம் இருக்கணும். ஏன்னா ஜே வந்து வேல்யூ நமக்கு 18 கொடுத்துருக்காங்க. ஸோ சிஸ்
Very good. Awesome. Awesome. So J value is given as 18 hertz. Alkene 6. Alkene or value 4 to 6. So 6 la 1 hydrogen, J value 18. Then 6.28 1 hydrogen doublet, J value 18. So trans coupling, trans protons. So the trans coupling. So the base பண்ணி எது ரூல் பண்ணிடலாம்?
ஆப்ஷன் 2 மேம்.
2 ma'am.
Option 2. Very good. 2. So trans coupling nala Fatima, 1 second guys. Fatima. So trans coupling. So what I can do, trans coupling, therefore I can rule out option 2 because this is cis coupling. Cis coupling will be nowhere be near 10 hertz. Avlodhan. So 10 to 12 hertz. So it is 18 hertz. So trans acno. So 2 rule out panniten. Very good. Next.
தென் 1 ஹைட்ரஜன் வந்து சிங்லெட்னு கொடுத்துருக்காங்க மேம்.
Very good. Pakka solving. Very good. So 6.8 1 hydrogen singlet. So என்ன அர்த்தம்? So aromatic region la 6.75 doublet, 6.90 doublet, and you have 1 hydrogen singlet. So totally 1 hydrogen, 1 hydrogen, 1 hydrogen. Aromatic region la 3 hydrogens இருக்கு. 3 hydrogens நால tri substituted now, okay. But அதுல ஒரு hydrogen singlet வந்து உட்கார்ந்திருக்கு. Singlet night has no neighboring hydrogens. அப்ப என்ன செய்யலாம்? Based on that, what I can say? Which option I can rule out?
Option 3.
3. Very good. Why? Because if I say this particular option, aromatic region la 3 hydrogen இருக்கு. This will be doublet, this will be triplet, and this will be doublet. So this will not give you a singlet aromatic, but here this you have hydrogen. This will be a singlet. And this will be doublet, this will be doublet. Very good, ma. Very good. So option 1. Now, paatona in the methyl neighboring 1 proton. So you can see 1.853 hydrogen doublet. So it is coupling with the alkene protons. So it is getting a doublet with a value of 6 hertz. And now this hydrogen is coupling with the methyl hydrogen and also this. So they have very different chemical shift values. So it will be split by the methyls as a quartet and then by the hydrogen as a doublet of quartet. So DQ, doublet of quartet. So this will be having a doublet of quartet. Why? Because it is coupling with the methyl to give you a quartet. Then it is also splitting with the neighboring hydrogen, so doublet of quartet. So DQ. Okay, doublets of a quartet. Okay, so you'll be having this 6.0 doublet of quartet where DQ one is 18 hertz, that is with the alkene protons 18 hertz, and with this particular it's having 6 hertz. So this has a 6 hertz and also 18 hertz. And now this hydrogen you have 6.28 1 hydrogen doublet. So this has 6.28. Then aromatic protons 6.75 and you're 6.8. Very simple, na? கொஞ்சம் டஃப் தான் பட் பாருங்க நம்ம வேல்யூஸ் இல்லாமே பேஸ்ட் ஆன் சிம்பிள் லாஜிக்கல் இன்ஃபர்மேஷன் நம்ம வேல்யூஸே பார்க்கல ஹர்ட்ஸ் வேல்யூ பார்த்தோம். ஸோ ஃபர்ஸ்ட் என்ன பார்த்தோம்னா இந்த 3.8. ஸோ இந்த மாதிரி ப்ரோட்டான்ஸ் இது 2.3 2 to 3 வரணும், இது 2 to 3 வரணும். ஆனா 3.8ல இருக்கு, 3.8ல இருக்கிறதுனால கண்டிப்பா இந்த இது பாசிபிலிட்டி இல்லைன்னு சொல்லிட்டோம். Then 18 hertz இருக்கிறதுனால I cannot have a cis bipair. Then since you have a singlet in aromatic region, this is also not possible. So based on simple clues, simple tricks, we are able to end up with the option 1. Is this okay, guys? Very good, ma. Very good. Okay. Now tell me this.
Option A, ma'am.
Option A. 1. Any other answer? What is this eta 6? What is all this stuff? Organochromium reagents. They come under organometallic reagents. Can you say this? Hope you have studied this in your PG. You might have studied this. So this comes under one kind of organometallic reagents. Okay, நீங்க படிச்சிருப்பீங்க. So carbenoids. So that is you have this organometallic reagents where you have this particular metal which is very important. Okay, so dots reaction la படிச்சிருப்பீங்க. Dots reaction. I'll show you. Okay, so this reaction, dots reaction படிச்சிருப்பீங்க இல்லையா? Fischer carbene. If you not just go through, இதெல்லாம் ரொம்ப நொசாக்கி reaction எல்லாம் படிச்சிருப்பீங்க. So அதுல very simple. When you have this chromium attached to the benzene ring, okay? So what happens is that when the chromium attached to the benzene ring, the chromium exerts an electron withdrawal effect on the benzene ring. What it does, it withdraws the electron. What does chromium do, guys? Tell me. What does chromium do? What does chromium do?
Withdraws the electron.
Withdraws the electron. So since it is withdrawing the electron, it allows a nucleophilic attack on aromatic ring. So benzene ring can undergo nucleophilic substitution reaction. Okay, so benzene can undergo nucleophilic substitution. I don't have reactions of that kind. Okay. So it undergoes nucleophilic. You can see this example. This example where you can see you have the chromium has attached, you have fluorine, you have electron with nucleophile attacking. Generally, we know that nucleophilic substitution benzene ring is a bit tedious because benzene is electron rich. So benzene generally evades the nucleophilic substitution reaction. If I want to have a nucleophilic substitution reaction, I need to have electron withdrawing group. So that is the role of chromium. So chromium withdraws the electron. So if chromium is withdrawing the electron, now tell me, what does chromium do? What does chromium do?
Deshields the proton of benzene.
Yeah. So it is withdrawing the electron away from the benzene ring. It is de-shielding it. De-shielding na high delta or low delta?
High delta.
So what is the answer? What is the answer?
Option 2.
Option B.
ரொம்ப simple question தான். என்ன இருக்கு நமக்கு தெரியாதனால we are just misleading it. Okay, so it is 7.2 வாய்ப்பே இல்ல. Something should happen. It cannot be so much de-shielded. வாய்ப்பே இல்ல. 4.5 no வாய்ப்பே இல்ல. It is getting de-shielded because chromium is withdrawing the electron away from the benzene ring. So answer is option 2. Is this clear, guys? Yes?
Small doubt, ma'am.
என்னமா?
One doubt, ma'am.
Yeah, tell me, ma.
ஜென்ரலா பென்சீன் வந்து நமக்கு அரோமேட்டிக்ன்றதுனால ரிங் கரண்ட் இருக்கும்.
ஆமா ஆமா
ஆகும்போது அந்த ரிங் கரண்ட் வந்து டிஸ்டர்ப் ஆகும் தானே மேம்?
ஆமா, disruption of ring current, that all is okay, but what you are seeing 4.5, it cannot be so much de-shielded. Shielding எப்ப நடக்கும்? electron donating எதால shielding நடக்கும். I am ready na disruption அதெல்லாம் okay தான், but இங்க inductive disruption கொடுக்கலையே. It cannot be 4.5. I agree with you that suppose you have a group which is withdrawing the electron, it will surely affect the ring current, but it cannot be shielded. 4.5 வரை வாய்ப்பே இல்லையா? This chromium, you have hapticity is 6. So you have back bonding, ligand to metal back bonding. So metal ligand la the metal ku enna pogudu, electrons pogudhu. So enna agudhu? So the chromium is withdrawing the electrons away from the benzene ring. So this is withdrawing the electron away from something like minus I effect, not plus I. Okay, so what is happening? So the electron density around the benzene ring is decreasing. So decrease adnal enna agum? It is getting de-shielded. So de-shielded enna agum? I should have high delta. 7.2 order delta value should increase. Do you get the point, ma? Point purida ma?
Yes, ma'am.
Okay. So disruption disruption or disturbance in the ring current is not the only answer. You should also think that on the disruption the chromium attach the chromium withdraws electron away from the benzene ring. There is an electron withdrawal effect. Since it is having electron withdrawal effect, the benzene ring becomes electron deficient. It can also undergo the nucleophilic substitution reaction. And the electrons come here at benzene ring. You get the point, ma? Yes?
Okay, ma'am.
Okay. Are you clear or not?
Yes, ma'am.
Two options straight away can rule out. No
4,
mercy.
ma'am. 1 and
1 and
4.
4.
Very good. 1 and 4 I'll rule out. Why? Because methyl 3 hydrogens kudukave illa. So 1 and 4 straight away gali. Now which is the answer? Very good. Very good. Very good. Now which is the answer?
Option 3, ma'am.
Option 3. Very good, ma. How, ma?
Because it is given that it is racemic mixture, ma'am.
Very good. So when you have a plane of symmetry, what does it become? These hydrogens becomes what do they become? They become
Meso
internal symmetry will give you what? What property will give you? Internal symmetry and plane symmetry will give you what property?
mesomeric.
Meso. Very good. Very good. Very good. Okay. Now tell me this. Quickly. You give me the answer, then we will discuss. அழகா ஒரு ஆப்ஷனை தூக்கலாம். அந்த ஆப்ஷன் என்னது?
A and B, ma'am.
A and B. Are you saying A and B, ma?
Okay, அது ரெண்டே ரூல் அவுட் பண்ணிடலாம்.
எப்படிமா? Why?
Because 4.4ல குவார்டெட்னு கொடுத்துருக்காங்க, மேம்.
ஓகே, நான் ஃபர்ஸ்ட் ஐஆர் வச்சு சொல்லுங்க. என்ன பண்ணலாம்? ஐஆர் வச்சு எதை சொல்லலாம்?
ஐஆர் வச்சு அமைட ரூல் அவுட் பண்ணிடலாம்.
ஐஆர் வச்சு அமைடே கொடுக்கலையேங்க. There is no amide here. Which one you are saying, ma? amide இல்லையேங்க.
சாரி மேம், எஸ்டர்
Amide. 2210 என்னப்பா? 2210 is coming. It is for triple bonded. So it can be triple bonded carbon or CN. ரெண்டுமே இருக்கலாம். சரியா? இப்போ எனக்கு என்னன்னா, this is alkyne. Alkyneல ஹைட்ரஜன் இருக்கும். இதோட ஸ்ட்ரெச்சிங் frequency என்ன வரும்? CH. alkyne என்ன எங்க வந்திருக்கும்? இங்க வேல்யூ எங்க வந்திருக்கும்?
3300.
Very good. I really appreciate. அதே NH2 வேல்யூ எங்க வந்திருக்கும்? broad peak ஒரு நல்ல strong peak 3400 கிட்ட ஒரு peak வந்திருக்கும். ரெண்டுமே மிஸ்ஸிங் இங்க. So this option is straight away ruled out. Based purely on IR. IR வச்சு நான் என்ன பண்றேன்? Option B தூக்குறேன். சரி, I am removing the option 3B. Option B based purely on IR. Now 2200 can be nitrile. இங்க nitrile இருக்கு, இங்க nitrile இருக்கு. Okay, so I have nitriles here. Now you can see that I have a triplet and quartet combination. So as she rightly pointed out, quartet is coming at 4.4. So triplet quartet na enna artham? What is this triplet quartet combination? What did I say already? Triplet quartet na enna artham? What is this triplet quartet? If I have triplet quartet, what does it mean? It is CH2, CH3. You have an ethyl group. So CH2 will be having a quartet, CH3 will be having a triplet. So triplet quartet combination means you have an ethyl group. Now this is coming as quartet, this is coming as triplet, and the quartet they have given us 4.4. This is 4.4. 4.4. This should come at 4.4. So here this is attached to C double bond. Oh, this will be around 223. அவ்வளவுதான் முடியும், அதுக்கு மேல முடியாது. So this is straight away ruled out. Guys, are you listening to me? Guys, are you listening? Yes?
Yes, ma'am.
Yeah. Okay, so they have not given the benzene protons. அவங்க discuss பண்ணவே இல்ல. அவங்க based on this they have answered triplet quarter வச்சு உங்களை solve பண்ண சொல்றாங்க. சரியா? So இது option இல்ல. இப்ப நம்மள்ட்ட என்ன இருக்கு option? I have option C and D in hand. Now tell me. Point 4. This cannot be so much de-shielded. So you have a lone pair of electrons here. It is going like this. So this is a plus charge. So highly de-shielded. So when you have O followed by C double bond, that will be highly de-shielded. Okay. Not only that, you have electron withdrawing from the other side. Okay. So this cannot have a value of 4.4. No. So the answer is option C. Is that okay, guys? Yes? Yes, all of you? Tell me, guys, is it that okay? What happened? Are you following, guys?
Yes, ma'am.
Yeah. So here you can see that you have triplet quartet. So in alkyne, you don't have this CH2, CH3. So based on that also you can rule out option B. Okay. So that option does not satisfy anything. Okay. So coming to this next problem, last problem, I think the last problem for today. Quickly tell me the answer.
Option 1 எடுத்துடலாம்.
Option 1 எடுத்துடலாம். Very good. ஏன்பா வைப்பா?
கார்பன் இருக்கு.
என்னம்மா?
9 இருக்கு. 9 கார்பன்.
9 கார்பன் இருக்கு. 9 கார்பன் இருக்கு. Okay. Okay. Next. Region you have 1 proton, 1 proton, 1 proton, 1 proton. Totally 4 hydrogens are left. So it should be what? It should be di-substituted. So B, C, D, moon di-substituted. Okay. And as he rightly pointed out, neither Gavni okay, but the chip based on that, I'll rule out 1. You have 9, 6, 7, 8, 9. 7, 8, 9. So RD. First okay. Now tell me, now உங்களுக்கு ஒரு clue கொடுத்திருக்கேன். இதுலயே நான் டிக் போட்டு clue கொடுத்துட்டேன். Now 5.3 1 hydrogen brought D2 exchangeable. எதெல்லாம் exchangeable hydrogen டக்குனு சொல்லுங்க. What are the exchangeable hydrogens?
OH, NH, COOH.
Very good, ma. OH, NH2, COH. So OH இருக்கு. மூணுலயுமே OH இருக்கு. Okay.
Option C rule out பண்ணிரலாம் மேம்.
Option C எப்படி rule out பண்றீங்கமா? Very good.
Substituted இருக்கு மேம்.
என்னமா?
Para substitute.
Para வந்து என்ன வந்திருக்கணும்? Doublet and doublet. அவ்வளவுதான். ஆனா இங்க என்ன கொடுத்திருக்காங்க? They've given a triplet, they've given a doublet, they've given a singlet, they've given a doublet. இது இந்த மாதிரி pattern எப்போ வரும்? When you have meta substitution. So para வாய்ப்பே இல்ல. Very good. Now it is meta substituted. Okay, I agree.
Option D rule out பண்ணிரலாம் மேம்.
Option D lock பண்றீங்க ஏன்?
நோ மேம், அது வராதுன்னு சொல்றேன் மேம்.
வராதுன்னு சொல்றீங்க ஏன்?
பிகாஸ் ஹெட்ரோ ஆட்டம் வந்து CH2 கூட அட்டாச் ஆயிருக்கு அப்படின்னா அந்த CH2 வந்து வேல்யூ நமக்கு 4.5 கிட்ட வரணும் மேம்.
Okay, the CH2, what value they given? 4.6. Okay, this is also CH2 attached to hetero atom 4.6 வர வாய்ப்பு இருக்கே. எப்பவுமே ஒரு ப்ராப்ளம்ல என்ன பார்க்கணும்? ப்ராப்ளம் ஃபர்ஸ்ட் என்ன செய்யணும்? ப்ராப்ளம் ஃபர்ஸ்ட் ரீட் பண்ணணும். An organic compound which does not change the color of ferric chloride. இங்க தான் க்ளூ இருக்கு. Which does not change the color of ferric chloride. னா அது வச்சு நான் என்ன பண்ணிருக்கலாம்? எந்த ஆப்ஷன் சேஞ்ச் பண்ணிக்கலாம்? தூக்கிக்கலாம்.
டி மேம்.
இது என்ன ஆப்ஷன்? Compound which changes the color of ferric chloride. எந்த மாதிரி compound ferric chloride color change பண்ணும்?
Phenols.
Phenols. Very good, ma. Very good. So என்ன சொல்றாங்க, which does not change. அப்ப it is not a phenol. அது phenolic compound இல்ல. அப்ப என்ன தூக்குறேன்? Straight away எது தூக்குறேன்?
Option D.
Very good. So first thing என்ன பண்ணும்? எப்போ ப்ராப்ளம் கொடுத்தா என்ன செய்யணும்? ப்ராப்ளம் ப்ராப்பரா ரீட் பண்ணும். So இவ்ளோ கன்ஃபியூஷன் தேவையில்லை. சார் D தூக்கிட்டோம், 9 கார்பன் வச்சு A தூக்கிட்டோம், சிங்லெட் ட்ரிப்ளெட் டப்ளெட் சிங்லெட் டப்ளெட் வச்சு C தூக்கிட்டோம். நான் வேல்யூஸ் பார்க்க தேவையில்லை. Guys, is this clear? Yes. So we will discuss only problems and recent questions plus the leftover problems. Gateless problems irukku. With that, we'll wind up. Then next class will be the last NMR class. Is that okay, guys? So koncham padichittu varingla, koncham revise pannittu varingla values ellathiyum. Yes.
Yes, ma'am.
Okay. Thank you so much.